Good day, everyone. This is Ruana Mayrez, and welcome to my YouTube channel. In this video, let's focus on derivative. Alright, derivative of a function can be denoted as f of x, y, dy over dx, df of x over dx, df of x, or dx of f. And also, we have Leibniz notation. Derivative of y with respect to x or dy over dx. So this is all about the rate of change of y is based on the change of the value of x. So those are the notations of derivative. Now let's move on to rules in differentiation and rules for calculating derivatives. So we must remember that a and b are differentiable function. A is equal to f of x and b is equal to g of x, and also c is constant. Alright, first rule, we have the derivative of a constant, which is constant rule. We have y is equal to c. The derivative of a constant, c, is 0. If y is equal to constant, then the slope of the graph is 0. So in every constant value, the equivalent is 0. Like for example, y is equal to 5. Therefore, its derivative or y prime is equal to 0. Alright, then next is the power rule. If we are given the function y is equal to x raised to n, therefore our derivative will be y prime is equal to nx raised to n minus 1. For example, we have the function of y is equal to x raised to 5 or raised to 5th power. Our y prime is equal to 5x raised to 5 minus 1. Since the value of our n is 5, then simplify, we have 5x raised to the 4th power. So this is our answers using the power rule. Next is the constant and exponent rule. In this rule, the power rule and the constant rule are being combined. For example, if we have the function y is equal to cx raised to n, the derivative would be y prime is equal to cn x raised to n minus 1. Here, we need to find the constant and its n value. Alright, for example, we have the function y is equal to 4x raised to the 6th power. So our constant is 4 and the exponent is 6. Now, by using the derivative, y prime is equal to 4 times 6 x raised to x minus 1. So, simplify, we have 24x raised to the 5th power. So, using this constant and exponent rule, this is how we should solve that. Next is derivative of a sum or sum rule. So here, if we are given the function y is equal to a plus or minus b, then we need to derive it using y prime is equal to a prime plus or minus b prime. Alright. Okay, for example, we have y is equal to x raised to the 4th power plus 3x raised to 3 to the 3rd power or x cubed minus 5x plus 3. Then it is y prime is equal to 4x cubed plus 9x squared minus 5. We are using here the power rule and of course the constant rule. So since our from the function x raised to the 4th power, once we derived it using the power rule, we need to put the exponent here using the power rule. 4x cubed plus then 3 times the exponent, which is 9, and 3 minus 1 is 2. That's why we have here the 9x squared minus 5x. So same process. And since our 3 is a constant, this will be equivalent to 0. That's why we have this derivative of the functions given. So that's how we derive a sum using the sum rule. Let's proceed. So we have here a derivative of a product, or should I say product rule. So if we are given a function y is equal to ab, then its derivative form would be y prime is equal to ab prime plus ba prime. All right. So let's try and have an example. For example, we are given the function y is equal to x squared plus 1 times x cubed plus 4. First, let's identify the value of our a, which is the value of our a and b. So which is the value of our a is this quotation, x squared plus 1, and the value of our b would be x cubed plus 4. Now let's derive it. Let's derive it using the y prime is equal to ab prime plus ba prime. So the value of our a is x squared plus 1. So we write it here. Next is the b prime. We need to derive the 3x. We need to derive the b, which is x cubed plus 4. Now we have 3x squared. So since we used here the constant rule, plus, since it is a written in a product rule, b a prime. So the value of our b, let's write it down. We have x cubed plus 4. Now let's derive the value of a. So since it is x squared plus 1, we derived it with the value of 2x. Now let's simplify. So we have here a 3x raised to the 4th power. We need to multiply these sides. We have 3x raised to the 4th power plus 3x squared, distributive property, plus still distributive property. We have 2x raised to the 4th power plus 8x. Now evaluate. Let's evaluate it. So we have 5x raised to the 4th power plus 3x squared plus 8x. So that's how we derive a product rule.